Okay, so you know how everyone's always saying, stay ahead of the curve. Like, you got to know what the next big thing is, right? Well, that's what we do here on the deep dive. We take these complex topics and break them down so you can actually, understand them without getting lost in all the technical stuff.
Exactly. No jargon overload here.
Yeah. So today, we're diving deep into something that honestly sounds like it's straight out of science fiction. We're talking about the connection between AI, you know, artificial intelligence, and something called quantum computing.
And it's a connection that's way more profound than you might think at first glance. We've got some really interesting source material here suggesting that AI is actually becoming a key player in making quantum computers a reality. In fact, one of the sources even goes so far as to say that some of the most exciting progress in this field is coming from what they call a relatively unknown approach. And that's what really intrigued me, this idea that there's this whole new path emerging and AI is right at the heart of it.
Yeah, it's pretty mind-blowing stuff when you really start to think about the implications. I mean, quantum computing, at least in theory, has the potential to be absolutely revolutionary, right? Like calculations that would take our best supercomputers, years, centuries even. Quantum computers could potentially do in like minutes.
That's the promise, and it's a promise that's attracting a lot of attention, particularly in fields like finance. I mean, think about it. The ability to make complex financial calculations at speeds that are just unimaginable with current technology. It's not hard to see why places like Wells Fargo, Citigroup, HSBC, Bank of America, they're all pouring resources into this.
Yeah, one of our sources even quotes this guy, Himim Israel from Bank of America, saying it's bigger than fire.
It's a pretty strong statement, and it really highlights the financial motivation driving a lot of this research.
Definitely. Though the sources do also acknowledge, kind of humorously, that there's a lot of hype around quantum computing too. Like, some people think it'll magically solve all the world's problems overnight.
Right, like we'll suddenly have cures for all diseases, and we'll be able to predict the future with perfect accuracy.
Or even bring back, Elvis.
Well, maybe not that. But yeah, there's definitely a need to temper some of the more outlandish claims. But even if we strip away the hype, the core idea of dramatically accelerating computations, particularly in fields like finance, that's still incredibly powerful.
Totally. So that's what we want to explore in this deep dive. How exactly is AI playing this crucial role in making quantum computers work? And specifically, we're going to focus on one of the biggest hurdles in this field, errors. So why are errors such a massive problem in quantum computing?
Well, to understand that, you have to understand a little bit about how quantum computers work.
Hmm.
They rely on these things called qubits, which are like the quantum equivalent of bits in a regular computer. But the thing about qubits is that they're incredibly fragile. They're super sensitive to any kind of disturbance from their environment. And the more qubits you have in a system, the more likely they are to be affected by these disturbances, which leads to errors in the calculations.
So it's like the more complex the calculation, the more likely it is to get messed up by these tiny little errors.
Exactly. And that's been one of the biggest challenges in building larger and more powerful quantum computers. Because if you can't control the errors, the results become unreliable. It's like trying to build a house of cards in a windstorm.
Okay, that makes sense. So how does AI come into play here? Is it actually able to fix these errors?
It's not so much about fixing the errors directly as it is about learning to predict and manage them. And one of the most exciting examples of this is the work being done by Google AI. They've developed this system called AlphaQubit that uses AI to reduce errors in their superconducting qubits.
So tell me more about that. Superconducting qubits, what are those exactly?
Well, they're basically tiny electrical circuits that operate at extremely low temperatures, like close to absolute zero. And at those temperatures, they start to exhibit these quantum mechanical properties that make them suitable for use as qubits.
Okay, so Google is using AI to work with these superconducting qubits. How does that actually work? Are they like training the AI on how these qubits behave?
Exactly. They've trained their AI algorithms on a massive data set collected from their Sycamore chip, which is one of their quantum processors that uses these superconducting qubits. And by analyzing this data, the AI learns to identify patterns in the errors that occur.
So it's like the AI is studying the behavior of these qubits and figuring out what causes them to mess up.
Right. And once the AI has this understanding, it can then use that knowledge to provide active feedback to the quantum system. It's like having a really smart assistant constantly monitoring the qubits and making tiny adjustments to keep them on track.
So it's like anticipating the errors before they even happen.
In a way, yes. The AI is constantly analyzing the state of the qubits and making subtle adjustments to the control signals that govern them. And the result is that the error rate actually goes down.
That's pretty amazing. So how much does this AI actually improve the error rate? Like, does it eliminate the errors completely?
Not completely, but it does make a significant difference. Our source even mentions that there are these red curves in their data that show the improvement achieved by the AI.
But it doesn't sound like the AI is actually reducing the fundamental error rate of the qubits themselves, right? It's more about mitigating the effects of those errors.
That's an important point. The AI isn't changing the inherent properties of the qubits, but what it's doing is making the system more robust and reliable. And that's really important because it means that you can perform longer and more complex calculations without the errors completely overwhelming the results.
I see. So it's not a magic bullet, but it's a significant step forward in making quantum computers more practical.
Absolutely. And what's particularly exciting about Google's approach is that it seems to be very generalizable. This means that the AI's ability to reduce errors works not just on the specific quantum states it was trained on, but also on new states that it's never seen before.
And why is that important?
Because it means that the AI's error correction capabilities can potentially scale up as quantum computers become larger and more complex. And that's crucial if we want these machines to be able to tackle real-world problems.
That makes sense. But you mentioned earlier that you're personally a bit skeptical about superconducting qubits being the best way to build quantum computers. Why is that?
Well, it has to do with the inherent challenges in scaling up these systems. Superconducting qubits are incredibly sensitive to noise and disturbances, and maintaining the right conditions for them to operate properly becomes increasingly difficult as you add more qubits.
So it's like a logistical nightmare trying to keep all these qubits happy and working together.
Pretty much. And that's why some researchers are looking at alternative approaches to building quantum computers. And one of the most promising alternatives is something called neutral atom arrays, or as it's sometimes called, atoms in tweezers.
Atoms and tweezers. That sounds like something out of a science fiction movie. How does that even work?
It's actually a really elegant approach. It involves using lasers to trap individual atoms in these very precise ordered arrangements. And each of these atoms can then act as a qubit. So you're basically creating this perfectly regular lattice of atoms, all held in place by these laser beams.
So instead of these delicate little electrical circuits, you're using actual atoms as your qubits.
Exactly. And that has some really significant advantages. For one thing, atoms are inherently identical, so you don't have to worry about variations in their behavior like you do with superconducting qubits. And because atoms are so incredibly small, you can pack a lot more of them into a given space, which means you can potentially build much larger and more powerful quantum computers.
Okay, so that makes sense. But why haven't we been building quantum computers this way all along? If it's so much better, why did everyone focus on superconducting qubits in the first place?
Well, it all comes down to control. Manipulating individual atoms with such precision is incredibly challenging. But that's where AI is starting to play a major role again. It's enabling us to achieve levels of control that were simply unimaginable before.
So how is AI being used in this atoms and tweezers approach?
One of the biggest breakthroughs has been using AI to precisely position and control these atoms. It's actually pretty similar to how Google is using AI for error correction with superconducting qubits. The AI is trained on data about how the atoms behave, and then it uses that knowledge to control the lasers that are manipulating the atoms.
So it's like the AI is learning to be this incredibly skilled atomic puppeteer.
Exactly. And the results have been pretty remarkable. One of our sources even describes this amazing atom tomography image that shows over 2,000 atoms arranged in this almost perfectly ordered array.
2,000 atoms. Wow, that's more than double the number of qubits in IBM's largest quantum computer, right?
That's right. And it really highlights the potential scalability of this approach.
But I guess the big question is, have they actually done any calculations with this 2,000 atom system yet?
Not yet. The main achievement so far has been demonstrating this incredible level of control and the ability to create these large, well-ordered arrays. But the progress in this area has been really rapid, and a lot of experts believe that performing meaningful calculations with these systems is just around the corner.
So it's still early days, but there's a lot of excitement about the potential of this atoms and tweezers approach. And it seems like AI is playing a crucial role in making it all happen.
Absolutely. And what's even more intriguing is that AI's involvement in quantum computing isn't just limited to these practical engineering challenges. It's also starting to raise some really profound questions about the fundamental nature of reality itself.
Okay, now you're really piquing my curiosity. What do you mean?
Well, it has to do with the concept of quantum randomness. One of the core principles of quantum mechanics is that certain aspects of the quantum world are inherently unpredictable. You can't know for sure what the outcome of a measurement will be, only the probability of different outcomes.
Right, I remember learning about that in physics class. It's like the universe is playing dice at the subatomic level.
Exactly.
Yeah.
But here's where it gets interesting. If AI can become really good at predicting and controlling the behavior of quantum systems, even better than our current theories suggest is possible, it might imply that what we perceive as randomness isn't truly fundamental. It might just be a reflection of our limited understanding.
So you're saying that AI might be able to see patterns and order in the quantum world that we're currently blind to?
That's one possibility. And if that's the case, it could have some pretty profound implications for our understanding of how the universe works. It's like if AI can predict the roll of the dice, maybe the dice aren't really random after all.
Wow, that's a mind-blowing thought. So not only is AI helping us to build better quantum computers, it might also be giving us a whole new way of looking at the universe.
It's certainly a possibility that's worth considering. And it really highlights the incredible potential of this convergence between AI and quantum computing. It's a field that's moving incredibly fast, and the discoveries being made are challenging some of our most fundamental assumptions about the nature of reality.
Okay, so let's recap what we've learned in this deep dive. AI is playing a crucial role in advancing the field of quantum computing. It's helping to overcome the significant challenges of errors, and it's also enabling the development of these new, more scalable architectures like neutral atom arrays.
Exactly. And it's all happening much faster than anyone anticipated. It's safe to say that quantum computing is going to be a major force in the near future, and AI is going to be right there at the forefront, driving the progress.
So one last thought for our listeners to ponder. If AI can become so adept at controlling and manipulating quantum systems, what does that say about the limits of our current understanding of the universe? Is it possible that what we perceive as fundamental randomness is actually just a complex tapestry of order that we haven't yet learned to decipher? And if AI can unlock those secrets, what other incredible possibilities might it reveal? Thanks for joining us on this deep dive.
It's been a pleasure. Till next time.